This is Unit 7, Physical Behavior of Matter. Lesson 8, Vapor Pressure. How is boiling point defined? The objectives of this lesson: I can determine the vapor pressure and boiling point of a substance using Table H. So do now. You can use your notes to find those graphs. Don't give me the excuse that you couldn't see it because my face was covering it up. You have your notes. They should be out. Okay, evaporation are when the molecules at the surface of a liquid gain enough energy to overcome their IMFs and change to a gas. This causes the pressure to build up above the liquid. This is our vapor pressure. So when we evaporate a liquid and we have an open container, it just goes away. But if we close the container, evaporation will reach an equilibrium with the liquid at the surface, and this is said to have reached saturation. So that's like if you have your closed water bottle and you see that condensation building up on the inside, that means I have an equilibrium between gas and liquid inside that bottle. So vapor pressure is defined as the pressure exerted by the vapor or the gas above a liquid at equilibrium. So if I were to close a container, I can actually measure the vapor pressure of a liquid, and each liquid will have a different vapor pressure due to its evaporation because they have different IMFs. So the liquid vapor equilibrium, some of the gas particles will condense, and then we find both evaporating and condensing occurring at the same rate. So when we have them at equilibrium, the rate of evaporation is equal to the rate of condensation. So this is an important point to take note, an important definition. So initially, when I first cover it up, all I have is evaporation. After some time, I have mostly evaporation and condensation begins to occur. And then at equilibrium, the amount of evaporation and condensing is equal. The rate. Okay. Boiling occurs when the vapor pressure becomes equal to or greater than the atmospheric pressure. So the vapor pressure of my liquid, whatever that is, will boil when the atmospheric pressure um, is less. Is less. So at normal atmospheric pressure, we call this normal boiling point. So that's on your table H, which you'll look at in a minute. So make sure you're getting your reference table out to look at. The pressure, how a pressure affects boiling points. So, for example, at higher altitudes, such as my hometown of Denver, Colorado, air pressure is much lower due to decreases in the amount of air molecules. It's a mile high, so that means there's a mile less of pressure on top of it. Therefore, water boils at a lower temperature and food actually takes longer to cook. However, at lower altitudes, the opposite is true. The boiling and attractive forces, or our intermolecular forces. So, boiling occurs when heat energy overcomes the attractive forces between molecules. So, the stronger the IMF, the higher the boiling point. It takes more energy to break the forces of attraction between particles. The weaker the IMF, the lower the boiling point. Therefore, it takes less energy to break the forces of attraction between particles. So, what's the difference between evaporation and boiling? Evaporation occurs only on the surface. This occurs only on the surface. However, boiling can occur throughout the entire sample. So that's why you see bubbles build up on the inside, because when I boil it, I'm putting energy into the entire sample. So now the IMFs are being broken everywhere. Evaporation is the IMFs are just being overcome at the top, where they're overcoming that atmospheric pressure. So table H is the key that you need to be able to use. This dotted line right here represents normal boiling point. So at 101.3 kilopascals, these four liquids, their normal boiling points, you'll notice, are different. The way to read this table: what is the vapor pressure of ethanol at 40 degrees Celsius? So I'm going to take the temperature they gave me. I'm going to go over to 40 degrees Celsius, which is not where this arrow is. It should be right here: 25, 30, 35, 40. I'm going to go up to ethanol, which is here, this line. Read it across, so it is in the right line. Read it across to the pressure, Each line here is 10, 20, 30, 40, 50. So it's actually about just under 20. So yeah, 17 kilopascals. So that's how I would read this table. So another example, what is the boiling point of water at a pressure of 30 kilopascals? So if they give me the pressure, I'm going to start on the pressure side. So 10, 20, 30. Read all the way across the line to 30 until I intersect the water line, which is here. So at 30 kilopascals, I'm at 70 degrees Celsius. So that's the boiling point when I have a different pressure, 70 degrees Celsius. So check your understanding. See if you can read this table. Okay, and again. Okay, you can now determine the vapor pressure and boiling point of a substance using table H.